Guys, welcome to the eighth OLake Community Call. If you have been hooked up to the previous community calls we had a really good offline meetup recently where we put forward our various offerings, predominantly being the OLake UI and everything. So if you have experimented with it, pretty good. But if you haven't, no worries. We will set it through in this particular demo. We have a good aligned demo with all the features, everything synchronized, so you won't have to worry anything about that. So let's get our agenda sorted, shall we? So firstly, we have the new features and the business impact. So in the past few months, our complete organization, the engineers were building on some new features. And at the same time, the four important core features that we have went ahead and completely synchronized is what we'll be covering on today. But at the same time, it's necessary that before we dive into the features right away, we would also be joined by a good end-to-end demo by Kshitij over here. And he would be going ahead and taking things from Oracle towards the production. That's Oracle's the recent connector we have implemented. So feel free if you have some questions, you guys can go ahead and put them forward in the questions bar over here, and our team will go ahead and answer them. Maybe at the last or at the same time, we have our contributors that will be actively participating in the chat, so you can put forward your various questions over there as well. So feel free to do that. So what's new in OLake? Firstly, we have been joined by Oracle GDC connector. What it is, consider that we have earlier, we have various databases that have been implemented in our organization. We had the MySQL, we had the Postgres, and at the same time, we have been joined by Oracle. This particular feature is something that organizations are rapidly adapting. You might have seen that Oracle and the various databases around have been rapidly being adopted by the organization, and that's where we have implemented Oracle as one of there. And then we have the advanced filtering as the very next feature. So what it is, consider you have your company and your organization and you don't want to take care of the historical data and you have your various compliances going through. You don't have to worry anything about that. So you can imply a simple filter feature and it will take care of everything around that. And incremental sync, as stated, you might have seen full refresh as one of our features in the OLake and how we support that. But at the same time, we would be taking care and punching up a notch by adding incremental over there as well. So it's going to support full refresh as well as full refresh plus incremental. So if you have your own data and you want to go ahead and synchronize it and you have your own organization that doesn't support the CDC needs, you guys can implement incremental sync over there. And then the Helm deployment, which as stated, all of these features would be very much implemented and showcased by Kshitij. He will be showcasing how Helm works and everything works around that. So the new Oracle source connector. You can see how it looks over there on the OLake UI. This is the recent one that we have joined in our complete family of databases. MongoDB, Postgres, MySQL exist, and Oracle has been recently joined. So you guys can go ahead and implement your real-time and the low latency data replication over here. Okay, wait a second. Okay, wait a second, wait a second. Just wait a second, guys. We might have a little bit of an issue here, but no worries. We have sorted out it pretty fast. So let me just share my screen and you guys can go ahead and look there. So my screen will be visible. Let me go ahead and present this one for you guys. So getting things more of professional, you might be seeing my screen at a pretty much better rate now. So should it is visible, right? Yeah. Yeah, okay. So as stated, this is how it looks in OLake UI, one of the core offerings that we have over there in OLake. And as stated, we have our own database set that there to help you, and you have your own versions that you can select of OLake, and it supports full refresh and full refresh plus incremental. So not only one of the features, but we have also punched up a knot and supporting incremental over here as well. So not only here, we support it for all our different databases. So what are the benefits of incremental sync? One of the core differences we can say, if you have an organization, no one likes to be taking care of the various compute costs, right? So that's where incremental sync benefits helps you. You guys can go ahead and process the changes that have been recently occurred. It propagates them through. And not only that, it minimizes your computation resources. So it takes care of all of that. And all of that can be taken care of by simply the click of a button over there on OLake UI. So if you would have experimented with OLake UI, this is the third step that comes along where you have been seeing stream selection. you guys can select there as full refresh was incremental. And if your organization doesn't support CDC, that was one of the core needs implemented incremental over here. So it takes care of that and propagates the data through without any issues. And then the filtering. Filtering has been one of the core features that we have been building upon, and at the same time, it would be also provided to you in the demo. But what was the need around it? A lot of organizations we have heard have one of the issues of regional compliances. Some of the data of users have to be filtered around, so the organizations can get the data propagated only the ones that they require. That's where filtering comes into use. And not only that, you can do again by a simply click of a button, you can further granular level, you can target the various columns and whatever data you want to propagate through. So as stated, you have a faster query performance and a better quality of data at the same time. Everything, the data gets filtered and it gets propagated through. And then the simplified deployment, the Helm for Kubernetes. I guess this is one of the core features you guys be waiting for, and this would be taken care of by Kshitij, and he would be telling you all with a good demo, and then we will be taking the things further. So over to you, Kshitij.
Hey, thank you, Akshay. Thank you so much. And also, yeah, you could mute the mic. Okay. Thank you so much for that brief introduction, Akshay. Really, really appreciate it. And I'm really thrilled to be part of this community call, and especially with the future of Helm, right? So first of all, why Helm? Right? We know Kubernetes is a lot of manifest files, right? Installing and managing an entire application, an entire stack of an application, right, is a gruesome task. We want something simple, right? A simpler, just one command, and that's it. It just sets up everything for us, right? That is something which takes a lot of headache off from the DevOps people and also the SREs, right? Helm is a package manager. So basically, as you already know, right, we have 6 components, actually, right? 6 components in the OLake data stack, right? All of those components, if without Helm, to be managed manually, one by one, right? And since it has to be done one by one, we wanted something combined, something bundled, right? And Helm is that package manager for Kubernetes. So, for example, imagine, right, you are playing with a Lego set. You're playing with a Lego set, and your parents have just bought it in, and then you have a lot of bits and pieces, and you want to be creative with it, right? You want to create a Star Wars, a big fleet of that starship, right? So the end goal is that, but how do you structure all of the different pieces in that Lego set, right? Those Lego set pieces are what are the components in the OLake data stack, right? Helm, what it does is that it packages all of that and gives it to you in a consumable form. So, for example, and that Helm CLI will be that adult who will work with you and say, hey, okay, now that you have all of those different colors of Lego pieces, let's bundle them together, right, and make something meaningful out of it, right? That's what Helm does, right? It just gives you one single command, and then the entire OLake data stack can be installed within a couple of minutes. We've tested it, and it just takes 2.5 minutes, right? Pretty fascinating, right? Okay. Without much ado, I'll just go ahead and give you a demo of what it looks like, and how you can just go ahead and install it, right? I'll go ahead and share my screen. I hope you can see my screen now. Yeah. Okay. So we have the Helm document already live on our website, olake.io/talks. And under the install section, it's called Kubernetes installation, right? You can see what are the all components that this Helm chart is going to install, right? This thing, OLake UI, is the main is the main component, of that stack which the user will be interacting with, right? Then there is the OLake worker, which takes care of all the syncs and all the tests and discoveries of schemas, making sure that all of those processes work smoothly, right? Then we have Postgres SQL, where all your job metadata and workflow metadata is going to be stored, and then you have that super powerful workflow orchestration engine called Temporal, right? Then we have Elasticsearch, for which helps Temporal to get all the workflow information that are there, the running ones, the stopped ones, and everything, right? Then we have the sign up init. It's a small job which will set up the initial user for you, right? And you can see it's the user which is going to interact with the OLake UI component, right? Then there will be Temporal orchestrator, right? The OLake worker, right? The activity pods, which were the sync pods, the test connection pods, the discovery schema pods, right? And then you're going to have a shared storage. One thing which I'll like to point out, right, is that we give a fully fledged NFS server to you in case you want to go ahead with it, right? In case you don't, you could always bring about your own read-write many PVC, right? Then you have source databases, right? Then you have source databases, right? And then you have your data lake storage, right? The source database could be Postgres, Mongo, MySQL, or Oracle, which we are going to, the Oracle is the one we are going to showcase today, right? And then the data lake storage, which could be the Parquet format or the apache-iceberg, right? Prerequisites, okay. Kubernetes version 1.19 plus with an administrative access, obviously, to install all of the components. Helm 3.2.0 plus, right? And then there will be the kubectl, the kubectl is basically the Kubernetes CLI in order to talk to the API server, right? And then Helm obviously is the package manager. The CLI can be installed. We have attached the installation guide, which will link you directly to the official Helm installation guide, right? And the same goes for kubectl as well. So Helm, imagine it's like that Ubuntu package manager. You have to install MongoDB, so you have to first get all the information that is there in the MongoDB repository, right? So you just go ahead and add, first of all, the repository. As you can see, I had already added it prior to joining this call. So it says that OLake already exists, this Helm repo add, and then the name of the repository that's going to be stored on your local, and this is the remote link, right, where the Helm repository is stored. You can visit this link also. It's a beautiful page, which will tell you basically to do the same thing, right? Then we do an update. What an update does, right, is that it pulls all the latest charts that are hosted in that repository, right? Then you can obviously go ahead with the basic installation, Helm install OLake, which will be the Helm install OLake. So OLake will be the name of the name of the app that will be installed, and OLake/OLake. So this OLake is this repository that you have added, and this OLake is going to be the name of the chart. So the name of the repository and the name of the chart in this case is the same, but we're not going to do a basic installation this time. You could obviously go ahead and try it, and it works absolutely fine, but we're going to do a little advanced one for today. So I have a values file. So what we can do, right, with Helm is that we can, as I said, you can build a different kind of structure, your own creativity, right, with that Lego set, right? Remember, so you are that little kid who can put the Lego bricks in whatever format you want. So that is what we're going to do today. That we're going to be a little more creative. We're going to set the global environments. You can see the OLake worker that I talked about, the component. The repository is going to be the latest one. The tag is going to be the latest one. I've set up an environment variable here. You can obviously do that too. And then the OLake UI, right? Ingress is something very, very important. So for example, Kubernetes is a very tight, Akshay, I'll tell you, Kubernetes is a very tight ingrained ecosystem, right? So what happens, right, is when you install an application on Kubernetes, you can't access it right away, right? So you need some form of integration, right, with the cloud or with your on-premise system or whatever, right? Then you need some form of controller, right, which will make the service be accessible from the outside internet, right? So and we give this whole setup to you right out of the box. So you can set it OLake UI and then ingress. Currently, we have set it to false because we don't want to expose our deployment right away. But you can obviously do that when you install it yourself. So enabled could be true. Then the class name could be anything. The class name, obviously, any person who understands a little bit of Kubernetes can understand that class name is going to be the controller name, that ingress class controller name that's already been installed and configured, right? Host, wherever you want to host your OLake deployment at. So for example, cube.olake.io, right? And then the TLS, obviously you can pass in the certificate so that you can also the HTTPS, right? The init user can be set up, right? Admin user, username. For the simplicity's sake of this deployment, we're going to just call it admin, and then the password is going to be password, right? Obviously, big caveat, change this in production. Okay, so I'm going to quickly, deploy this with this value file, right? The command to do this is just -f, which is the file, right? And then the path of the file. So for example, I'm in the current directory, there is the values file, values.yaml. So I just go ahead and I install it, right? And I hit enter, and it's going to install this in the default namespace. So there is a default namespace on Kubernetes where by default, when you access the Kubernetes cluster, you're already always on that namespace. For example, you open up your Windows PC and you're always on the default user that is there, right? So you could obviously create multiple users, and that's what we just did there. So I could do a kubectl get pods. It's going to show me, hey, things are happening, right? Elasticsearch 0 is getting installed, that we talked about. And if a server comes out of the box, you could obviously bring your own persistent volume claim. And it's also part of the, again, let's take this time to talk a little bit about the documentation that we have. The user creation could also be done from a secret, right? Kubernetes has this thing called secret, and then you can obviously bring in a KMS encryption, or which is provided by your any form of encryption provided by your cloud provider, right? And then you have obviously the ingress configuration that we talked about, job-based node mapping, right? So every job on OLake has a unique ID, right? That unique ID can be mapped to a specific node, right? So for example, you have multiple jobs. For example, you want to do a full load and also do a CDC, but full load is on a big Postgres table, and the CDC is just running on a small MongoDB node, right? Now you obviously want a bigger machine for that PostgreSQL job, right? So what you can do, let's say the ID of that PostgreSQL job is 123, and you want to run it on the heavy machines. So you created a node pool with the label olake.io/workload type is heavy, right? So what happens, right? And it's just magically what happens, right? Is that pod for that activity of that Postgres sync goes and sits on that heavy one, so it can start consuming the memory and the CPU from only that node. And we also have something called as a pod anti-affinity. So for example, two jobs will not sit into the same node. In this case, what happens is, let's say one of the jobs starts consuming a lot of memory, and then the Kubernetes API, Kubernetes kubelet does a OM kill. Then what happens is both the pods are kicked out and both the jobs fail, right? We don't want that. We want only the job which we have maybe a little. We went a little early, and then we tried to set it up a little quickly, and we did not really have that scaling in mind. We don't want that job to kill the other job that is already running, right? But for example, for any job that you don't want to set it, the empty mapping is always passed for it. You don't have to do this explicitly. So empty mapping is just, okay, find any node on the cluster, just sit on it and do the job, right? Cloud IAM integration, I'll tell you what, security in case of jobs, Akshay, is very important, right? You don't want to pass your AWS secret keys and access keys there, right? What you want to do, right, is that you just want to create a service account on that Kubernetes cluster and associate it with that job, right? And that job can automatically pick up all the access credentials using an IAM role, right? For example, currently IAM role is also supported, GCP workload identity is also supported, and Azure workload identity could also be put in, right? You obviously can refer to the doc here. Encryption configuration, we have encryption, whatever data, job configuration, and all those secrets that you have stored, the username and password of the database is encrypted. You can bring in your own KMS key, also you can just create a string here, and then it will be used, it will be auto hashed to a 256-bit encrypted key, and then that encryption will be used. In this case, don't lose the key, okay? The persistent storage, which we talked about, you can set it to false and then bring in your own external PVC, right? That's how it goes. Again, let's get back to the implementation, right? To the installation. You can see, hey, we did the installation and everything looks deployed. Namespace is default. Test suite is none. Nodes. It says that OLake has been successfully deployed, right? Now since we did not install a ingress, right? We want it to be only internally accessible right now for the sake of simplicity, right? So what we are going to do, right, is we are going to port forward that service to our local, and then we can access the service on our local as well, right? And then we can just access it on OLake UI at localhost 8000, right? The username will be admin and the password will be password, right? As we had set up in the value files that we had set up. So let me quickly do that. Okay, cool. It started to port forward. I'm going to localhost 8000. I'm going to put admin. I'm going to put password, and I've logged in. Hey, accessible, right? You don't have to worry about any other thing. You can see all the pods work in sync with each other. Okay, let's create our first job. Let's create an Oracle one, since that is what we are showcasing today, right? I'm going to use the latest version, which is the 1.11, right? I'm going to name it Oracle, the name of the source. The host, I'm going to quickly copy it. I have it saved somewhere. We have that database on the cloud. So 1521 is the port. Service name is this. I'm going to quickly get the password as well. This cell mode is disabled. Right, I'm going to hit next, and magic is going to happen. You see, pod was spin up for the test connection. So nothing happens inside one pod. So all the sync and all the test connection and all the discovery are a different component altogether, right? Now we're on the setup of the destination side. We're going to set up an iceberg. We're going to use the glue catalog because we want to be able to quickly see our changes, right? We're going to use Athena for it. So later on, so I'm going to just use call it ice, the destination. Going to use the latest version again, and I'm going to name it Kshitij 2. Okay, I'm going to name it AP1. I'm going to copy my access keys. I'm going to call it OLake 2. Fine. Okay. Obviously, if you in case you decide to use the service accounts, you don't have to enter the access key and the secret key, right? You can see a test connection Oracle is running because we use the source as the Oracle, right? The pod is spin up and hey, this connection is successful. Now we get to select the streams. And this is where the magic happens, right? The new features we talked about. Okay, so for this example, right? I already have a table called salaries somewhere. Yeah, this one. So I'm going to select this table, right? And then we are going to do the full refresh plus incremental, right? There is something called as a cursor field. I believe you already talked a little bit about it, right? Cursor field is like the bookmark, right? So for example, you may have a lot of data on your table, right? And then more data comes in, and then you on full refresh, let's say 1 2 3 4 are the records that got ingested, and then at 4 the next bookmark is going to be there, and then the next time you run the sync, it's going to start from 5 6 7, right? In this case, we're going to set the cursor field to be updated at, right, which is going to be the time at which the salary got got changed, got modified, or got added, right? Fallback cursor is going to be ID. So cursor field, in case it's null, right, we're going to set it to the fallback cursor is going to be ID, which is going to be not null, right? So not null field, not null column, right? So what's going to happen is, let's say created at is null for one of the rows, right? In that case, it's going to fall back to the fallback cursor. Right? We're going to set the normalization to true, obviously, and the data filter. Here, I'd like to show you something. So let's say I have huge amount of rows in a table, right? And I only want to migrate selected rows, right? So I'm going to do an ID greater than equal to, so on my salaries table, I've created 6 right now rows. 1 2 3 4 5 6 are the IDs there, right? So I'm only going to select the IDs starting from 3 onwards. So 3 4 5 6 are going to be synced, right? And I'm going to do 3 here. So basically, that's how it's going to be. I'm going to hit next here. I'm going to set up the job. I'm going to name it job underscore OLake. I'm going to set it to week. I'm going to set create job, and the hey, job got created, right? And now let's set up the sync. Yeah, I clicked on sync now. I should see a sync. Pod is running. Hey, you could obviously cube ctl logs and then see the logs that are happening, right? Magic is happening. Something is happening. That's really great. You can also view logs on the UI real time. You can click on refresh. It's going to, so you can see. So you can see 3, 4, 5, 6, and 7. I guess I'm sorry, 7 of the records we copied. So let's go ahead to the console and try to try to see the. So I named it Chitish 2. Now I'm going to do a select star from salaries. I should see something. Hey, 3, 4, 5, 6, right? 3, 4, 5, 6 are those 4 rows that we had talked about, right? Got copied. Sorry, the one was for the test table, I believe. Yeah. So again, now what I'm going to do, right, is I'm going to run the sync again. But before that, I'm going to add one more row to the table. For example, a row with ID 7, right? I'm going to do it from my local now. Okay, so I've done it. Now if I run the sync, so for example, you can see it 3. So if we sort it 3, 4, 5, and 6, right? After that, we should see a 7 here, isn't it? Okay, we're going to run the sync now again. Right? It takes a couple of minutes to get everything up and running. Okay, hey, two records have been read. One is obviously the test one. Now, if we try to do this again, hey, we got our seventh. That's great. So this is a little bit of introduction of how Helm can ease your deployment of OLake stack onto your Kubernetes cluster, and I hope that was uh, uh, that was fine with you. Yeah. How does it look good to you? Does it look good to you?
Pretty good, pretty good.
Thank you.
So, let us continue towards the various things, right? So, as we have discussed all of the things around the demo and everything, and it was wonderfully presented us towards by Kshitij, and thanks a lot, all the demo gods work for us, and everything went fine, pretty good, and everything worked successfully. So, as you can see how awesome it is to go ahead and sync your data as fast as possible, and at the same time towards Apache Iceberg. And as you guys can see, that it's going ahead and being rapidly adopted. So that's where the need comes into time, and OLake is diving into the space. So as you can see, this was the complete flow of how the filtering and everything went through, how the sync and everything was implemented, and how Oracle was connected, one of our very, very early offerings. And then community resources. So if you guys are pretty much active over Slack or anything around there towards the social media platforms, we have been pushing various resources to guide you through the complete walkthrough of the Helm deployment, and everything has been also pushed through. You might have seen I had shared a link pretty here only, and there you might have go ahead and experiment from your end as well. And if you want to go ahead and want to interest yourself how we compare Apache Iceberg with the existing other open table formats, for example Delta Lake, you guys can also do that. Here's how we work around with the various walkthroughs of how you can implement it and create a complete open data lakehouse. Some of the ones that I have contributed to, others are the ones that people in my team have contributed to. So pretty good thorough approach on them. And if there are any ones that you want us to cover more, feel free to tell us around that, and we'll love to take them over. And then simple community impact at a glance. So as we are getting our numbers in, we are getting more and more numbers, and the people joining in. We have got a complete month of milestones over here. So firstly, we got over 1K stars on GitHub. So that was one of the thanks a lot to the team and all the contributors who have joined towards this path. And at the same time, more and more people are experimenting with OLake. So that's one of the great things. And secondly, LinkedIn is one of the places we have our highest followers. That's around 12,000 plus followers. We go ahead and approach with the various things. We tell our recent updates, whatever we have done, our new releases and everything are shared over LinkedIn. So you guys stay updated on that. And at the same time, here's our Slack. So there are around 280 members, and I guess soon they're gonna be 300 as we are having our own OLake Community Week going on. This is the second part of that. Like yesterday, we had our own session covering the various things around ClickHouse, and today we have our own OLake Community Call. And on September 4, we would have a session for Mersham. So it's going to be a complete week of discussions and everything happening over there on Slack. So make sure to join over there. And so as stated, beyond coding connectors, OLake is out there to help you stay in sync of whatever we implement, whatever new updates we push through, at the same time being updated about the Lakehouse movement. So calling all the contributors. This is the part where Shubham would like to take the lead. Yeah,
Hey,
Shubham is here. Yeah. Hi.
thanks for adding me as the host. Hey everyone, hello, back again. So, a couple of quick things on the contributors. Previously, we kind of put the contributions on a little bit of a hold because primarily we were working on one of the major refactorings when it comes down to the destinations pieces. So previously we used to have a destination code majorly written in like Java side of the things, where Golang used to just pass on the things to Java, and Java used to take care of sorting and ingesting into the iceberg, right? But recently we realized that Java part of the code was consuming a lot of RAM, and it was also taken from one of the other open source projects. We definitely needed to refactor it. So after refactoring, we have moved the major amount of code from Java to Golang, and Java is now acting as one of the kind of interface, a dummy interface, just to ingest the data into iceberg. So with that, again, like that removed a lot of redundant code from the Java part. We have basically done a lot of simplification in the Golang side, and now the protobuf object that we were passing as a gRPC call from Golang to Java, it's been simplified a lot. It's been restructured, which uses a lot lesser memory and maintains the order of the records which is being passed, so that we don't have to sort it again. And that is particularly really useful when we are ingesting into, let's say, some level of partitions and all. Apart from this overall simplification and restructuring resulted into 80% drop in the memory. So previously, if we are syncing around, like, let's say 50,000 record per second with 80% utilization, now vice versa, like inversely proportional, we are able to do 150,000 records per second in around the similar memory, right? So that's one of the benefits. And apart from that, like now basically you can run the workloads on a lot lesser memory compared to what was being done previously. Apart from this paves the way for us to include like two main features going forward, which we are happy to take a look at the contributions. For example, one of the features could be the dead letter column feature. So like the hypothesis here is, if some record comes into the sync which are not matching the schema of the iceberg table, we'll be putting them into one of the columns called a dead letter column, so that in case you don't want to break the sync, you want to keep on adding the data continuously, that will dump it as in a JSON format into the dead letter column, as most of the data engineers they do in the Kafka, like a in Kafka or any other streaming sources. But like that we are doing with the iceberg tables extra column. Apart from this so one of the things that we have also introduced in this refactoring is a separation of the schema management for the destination as well as the source, which is basically enabling this now. Because we have a separate schema for the destination, now we can actually be like, okay, now this column is not matching with the schema, so we should put the whole record into a dead letter column. Apart from this, one of the great advantages of the things that we did with like 1 month of refactoring is, now whenever we do the historical load of the data, the average file size that's being created is around 256 MB. So this is really important for the performance. Whenever we load terabytes or hundreds of terabytes of data in a historical snapshot, it will create the average file sizes of 256 MB consistently, which was not happening previous to this refactoring. Now this enables you to basically not do one more level of compaction after just the full load. You don't need to do a compaction which is going to save a memory and the time, and as well as the cost, right? You can simply run your queries. They will be as performant as a compacted table. And apart from that, we are definitely going to implement one of the highest ask features, which is, do we have a continuous listening mode for the CDC kind of a sync modes? And yeah, with the restructuring or refactoring, we are it's just a one step away from implementing that feature. So now, given that we have finished the refactoring, now we'll be calling to all the contributors, whoever has already raised the PR or whoever wants to raise the PR, will be with this refactoring, we can easily take your PRs, and it will be easier for you to contribute as well now, as the majority of the code is being simplified. So happy to call all the contributors who want to contribute. So that's all from my side. Happy to answer any questions if you have on the questions thread.
I guess there were only a couple of questions, and I guess those have been answered by Shital over here. And at the same time, as stated, we would like to go ahead and get some contributors in towards the complete community, as my prime focus is to go ahead and get not only those numbers, to get some contributors contributing. That's where our Slack community comes in. And we have our overall the contributions and everything being taken care of by the various people in our team. And then just moving on forward, if you guys are pretty much interested about everything, whatever we are doing in the complete Apache Iceberg ecosystem and how we are implementing the things, what are the new cool features we have added and what are the new cool features we can add, feel free to jump on towards our various social handles and wherever we put on forward these kind of things. I'm going to just quickly share the link on that. So if you guys are interested, so you can go ahead and join our Slack community. So that's where most of the important things going to be coming in soon. So more on that. I think most of the questions have been answered by the people over here, and we got some people answering them. And at the same time, a lot of the other questions would be taken up over Slack. Over weekend, we have discussions lined up over there. So if you have anything related to the complete meetup call we did, or any good sessions we can plan on for you guys, feel free to tell that. We have a couple of sessions every month, so stay tuned for them. And yeah, thanks a lot. Thanks a lot for joining in to everyone over here. It has been a great evening. Thanks a lot. It's been a weekday, so thanks a lot. You guys took out your time over there on the week, and we had some cool features waiting for you. More soon gonna be added. So more on then on the social update side. So we'll catch you guys soon on that. So
Awesome.
that's a wrap. Thanks a
Yeah,
lot.
one last thing I want to mention,
Yeah, sure.
Akshay, is we are also doing a full revamp of our documentation, and which is going to give a fully fresh look to the doc section, which is going to make it easier for the people to try us out, and also, it would be a lot easier for people to just follow the quick starts, because previously it was a little bit of a mess because there were a couple of duplications in the documentation. Now it's pretty much easier. So there is just one single flow, and you can follow it and quickly set up your syncs. And also, we are bringing a lot more cool features when it comes to the basically the documentation, including CIs and all. So stay tuned for that. Yeah, I think that's all.
Okay, okay. So great. Like that's how the open source and everything prevails. So as long as we have good documentation going on around, we would love to get adopted as soon as possible. So if you guys have any other questions, if you guys can pump them around, feel free to go ahead and do that over Slack. So that's a wrap. See you guys there in the next event. Bye bye.